These videos, this one in particular will be for November 22nd and November 28th. It's been a while, but we're going on new content. We're solving trigonometric equations. It might be helpful to have a unit circle out. That would be very beneficial to have because we might need it. We will need it. But let's start by looking at these four equations. Now, let's go through it and then I'll clarify. Here we have -1/2 equals sine of theta. So we're trying to figure out what values, right? What values for theta make this equation true. If we find more than one value for make an equation true, we need to list all the values that make this equation true. Well, here's the thing, right? We know that this will hold true if theta is such where sine is equal to -1/2, which we can do using the unit circle. So if you need to pause it, go get the unit circle, that might be good. Or if you already have it, that's great. Let's work with it. But if you look at the unit circle, remember the x is the y, or is the cosine. Cosine is the x coordinate, sine is the y coordinate. So where sine is -1/2 on the unit circle, one of those values is 7 pi over 6. Another one of those values is 11 pi over 6. And some people actually in class said, hey, what about -pi over 6? And what they mentioned was when we were dealing with arc sine, right? I'm going to draw a little here. Arc sine, we were only looking in these two quadrants. And if it fell in the fourth quadrant, it was going to be the negative of that angle. Yeah, so -pi over 6, right? But these two here, 11 pi over 6 and -pi over 6, these are actually coterminal. So they would give us the same value, give us the same output. And in general, we probably won't list this one. However, we do need to take care of it because we want all the values that satisfy this equation. So we could say -pi over 6. We could also say, if we were to say 11 pi over 6, if we add 2 pi, that would go all the way around the circle. We would end up there, back at 11 pi over 6. We can add these by getting a common denominator. So we could also say theta is equal to 23 pi over 6. Or theta is equal to 35 pi over 6, right? All of these values here would be coterminal with 11 pi over 6. And in fact, there's an infinite amount of these, right? However, we're not going to list all of these. That takes too much. We're just doing the most. So we wouldn't list all those. Instead, what we would say is, hey, let's add 2 pi. Because if we add 2 pi like we did here, we would end up with 23 pi over 6. But if we were to add another 2 pi, we would end up there. And we can keep adding 2 pi, and get values that satisfy this equation. Same thing if we subtract. If we were to do 11 pi over 6 minus 2 pi, we would actually get -pi over 6. So what we say here is we're going to add 2 pi, but we're also going to say 2 pi in. Okay? Same thing here. Same concept applies with 7 pi over 6. And the reason we're adding 2 pi in is because that takes care of every single coterminal angle. And here n is a whole number. So n can be negative, n can be positive, n can be 0. By adding 2 pi in, we take care of every single coterminal angle with 7 pi over 6, every coterminal angle with 11 pi over 6. And so these two sets of solutions are the solutions that make this equation true. A lot going on there. If you need to pause, rewind, that might be good, right? There's a lot happening. But let's keep going if not. Let's keep going, look at the next equation. So here if we want to solve for theta, let's say we divide by 2 to get cosine on its own. That might be good to get cosine on its own. And so we get cosine of theta is equal to square root of 2 over 2. Now we're trying to figure out where does theta, what values for theta, there'll probably be 2 of them, satisfy, so that if we take cosine of that angle, we get square root of 2 over 2. Well, again, cosine is x. One of those theta values is pi over 4, because at pi over 4, cosine is square root of 2 over 2. And the other one on our unit circle would be 7 pi over 4, because that value as well, cosine of 7 pi over 4 would be positive square root of 2 over 2. Now again, to make sure we take care of every single coterminal angle, every coterminal angle with pi over 4, we're going to add 2 pi n to that solution. Same thing here, we're going to add 2 pi n to this solution. And those are our two solutions. Sets, our two solution sets. Alright. Let's go over the next two. Probably just the next one actually. And then, well, we'll have to go to the next one too. Here we want to solve this equation. So let's say we add 6. Those go away, you get tangent of theta is equal to -1. Now here we need to be careful, right? We should know something about tangent. We should know that tangent is sine divided by cosine. So if once we get here, we need to look and think, where on the unit circle with theta, if we do sine divided by cosine, will we get -1? Well, what we will do here is think, something divided by itself would give us +1. So if we had something divided by its negative self or vice versa, that would give us -1. So if you have your unit circle, take it out and look. At pi over 4, you have something divided by itself, right? You have square root of 2 divided by square root of 2 over 2. So that would be +1. We want -1. Well, let's look at 3 pi over 4. At 3 pi over 4, you have positive square root of 2 over 2, because sine at 3 pi over 4 would be positive square root of 2 over 2. Cosine would be negative square root of 2 over 2. Positive something divided by its negative self would give us -1. So one of these theta values would be 3 pi over 4. Let's see if there's another one. Let's keep looking. Keep going around. 5 pi over 6, not going to work. Pi, no. 7 pi over 5 pi over 4. Let's take a look. Both are negative. Negative square root of 2 divided by negative square root of 2. If you have that, then we have a negative divided by a negative. That would actually be a positive, so that's not going to work. But 7 pi over 4 will, because we have negative square root of 2 over 2 divided by positive square root of 2 over 2, which would be -1. And so those are our two reference angles, if you will, and then we add 2 pi n. All right. Real quick, and then we'll go end this video and add another one. Here, if we were to solve this equation, we want to get cosecant on its own, right? So -2, subtract 2 on both sides. Those go away. Then since it's -5 times cosecant, we would divide both sides by -5. This would be 1. We get 1 is equal to cosecant. Now, what we talked about in class is it would be great if we could get this on the unit circle, and we can, because we know that cosecant, the reciprocal, so we're going to take the reciprocal. We should know this from the previous unit, right? The reciprocal of cosecant is sine. And we can do this. We can take the reciprocal of this side and make that sine. However, if we do that to this side, we have to do it to this side as well. It just so happens that the reciprocal of 1 conveniently is 1. So this is something that we can do. We can take the reciprocal of one side as long as we take the reciprocal of the other side. Now we look. Where on the unit circle does sine equal 1? And the only theta value where sine equals 1 is pi over 2. And then we add the 2 pi in to take care of all the coterminal angles. If you need to pause, rewind, that might be good. I'm going to end the video here. If you have questions, reach out, and I'll post another video doing 1 through 4 on the bottom part of the page.